students, welcome back to my YouTube channel. In this video I am going to discuss about acceleration. So if you see a car is to be moving in a road, after some time the driver press the accelerator, its speed is increases. So we can say that if the speed increases, it is accelerated. Speed of a object increases, we will say that it is accelerated. Okay, then after some time the driver press the brake, so its speed is decreased, so we will say that it is to be decelerated or it is retarded. Okay, this we will define it mathematically. What is acceleration? Acceleration is the rate of change of velocity with respect to time. That means velocity, how much change in velocity with respect to time. In unit time, how much is the velocity changes. That is the acceleration. Okay. Acceleration is equal to change in velocity divided by time. Okay, what is change in velocity? Final velocity minus initial velocity divided by time. Okay, so we can be final velocity minus initial velocity divided by time. That is the acceleration. Acceleration is a what type of quantity? Acceleration, it is the change in velocity divided by time. Velocity is a vector quantity, so the acceleration also a vector quantity. Okay, and what is the unit? Velocity unit is meter per second, so the acceleration unit is meter per second square. That is SI unit. CGS unit is centimeter per second square. Okay, then this acceleration may be positive, negative or zero. When it will be positive? Okay, so we will say that positive acceleration. Positive acceleration. Okay, so you see this. The acceleration is final velocity minus initial velocity. If the final velocity is greater than initial velocity, that means when the speed increases, we can say that the acceleration will be increases. So that time the acceleration value is positive. So we can say that velocity increases. That means final velocity greater than initial velocity. This is the case of positive acceleration. When the acceleration is to be negative, negative acceleration. You see this, if the final velocity is lesser than initial velocity, this acceleration will be decreases. That means acceleration is to be a negative one. So if the velocity decreases, we will say that acceleration is negative. So velocity decreases, or we can say that final velocity is lesser than initial velocity. Okay, that is to be the negative acceleration, and the acceleration is 0. zero acceleration. In zero acceleration means initial and final velocity is to be equal. That means an object is moves with a constant velocity. We can say that the acceleration is to be zero. Otherwise, we can say that the object is in uniform motion. Acceleration is to be zero. Uniform motion. Velocity value is constant. Okay, this time the acceleration is to be zero. Okay, then next we will see about what is uniform acceleration. If an object is to be moves equal time, there is a equal increases in the velocity. Always there is a particular increases in the velocity. That means you can take it as an example. I am considering uniform acceleration. Uniform acceleration. Okay, I am taking an example. Initially, the object is to be started at t is equal to 0. Initial velocity u is equal to 0. After 1 second, velocity is equal to what? 1 meter per second. Next 2 meter per second. Next 3 meter per second. Next 4 meter per second. T is equal to 2 seconds. And t is equal to 3 seconds. T is equal to 4 seconds. You see this? In between this, how much is the velocity increases? 1 second. In 1 second, 1 meter per second velocity is increased. Here also, in 1 second, 1 meter per second velocity is increases. That means equal change in the velocity in equal interval of time. That time we can say that the acceleration is constant. The object is in uniform acceleration. Okay. Equal interval of time. Okay. An example of the uniform accelerated motion is freely falling body. That is a uniform accelerated motion. Okay. Then next, if this acceleration value is not to be uniform, that means the acceleration is not to be constant. We can say that the object is in variable accelerated motion. Variable acceleration. Variable acceleration, a value is not constant. That means we will take an example like this. Initially t is equal to 0, u is the velocity. Next, after 1 second, 2 meter per second. Next 2 second, 5 meter per second. Next 3 second, it is to be 10 meter per second. You see this? Here it is to be what is the acceleration here? Here. We take it, the acceleration here 3 meter per second square you will get. Here how much? 5 meter per second square you will get. So in this motion, the acceleration is not to be constant. Then we can say that it is in variable accelerated motion. Okay. So if an object is in variable accelerated motion at a particular interval of time, we need to say how much is the acceleration of the body. For that we are using average acceleration. Average acceleration. It is the ratio of total velocity change to the total time. Okay, so average acceleration is how much? how you can find out the average as a total velocity change. Total change in velocity. Total change in velocity divided by total time. Okay. Divided by total time. Okay, that is the average acceleration. Okay. If this is the thing, so this is the t is equal to 0, u is equal to 0. Okay. I want to find out what is the acceleration in this interval. Okay, so VAVG is equal to what? What is the total velocity change? That means final velocity is V2 minus V1 divided by total time, that is T2 minus T1. This I can write it as delta V divided by delta T. Change in velocity divided by change in time. Okay. So if I need to find out what is the acceleration at a particular instant, I am using instantaneous acceleration time. Okay. Instantaneous acceleration. Acceleration at a particular instant. Particular instant. That means exact at a particular time. What is the acceleration? If in this motion at a particular time, if I take it as a time, that is at exactly a t time, what is that? What is the acceleration of this body? That means at 10 pm or 10:10, what is the acceleration? So that means you see this time interval is reduces to and it is to be very closer to 0. That means instantaneous acceleration is the limiting value of average acceleration when delta t tends to 0. This value decreases and it is to be a particular instant we'll get. Okay. So instantaneous acceleration is the limiting value of average acceleration when delta t tends to 0, that is approaches to 0. Delta t tends to 0, delta v divided by delta t. What is this? This we can write a derivative of velocity with respect to time, that is the acceleration. Okay. This also we can write like this because v is equal to delta x divided by delta t. Substitute it here, so a is equal to what you get? D by dt of dx divided by dt. Okay, so what you get? That is d square x divided by dt square. Okay, this is the acceleration, another form. Okay. That's all about the acceleration.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.